here we have three different numbers, and we're going to write each of these in scientific notation. Now, the purpose of scientific notation is to write very large or very small numbers more easily and efficiently. And scientific notation is especially useful in fields like science and engineering, where you often deal with extremely large quantities like the distance between stars, and extremely small quantities like the distance between atoms or the size of atoms. So let's go ahead and jump into our first number right here. And the first thing to identify is if our number is greater than or less than 1. And we see here that this number is actually less than 1. We see that decimal point right over there. The second thing to identify is the first non-zero number. And now we take a look, and our first non-zero number is this 7 right over here. So 7. So we go 7 multiplied by 10. We multiply it by 10 when we write scientific notation. And then we count up, hey, how many digits are leading up to and including that first non-zero number? How many spaces, how many digits, however you want to think about it, how many numbers are leading up to and including that first non-zero number? And we can just count that. Go 1, 2, 3, 4, 5. There are 5 numbers leading up to and including that first non-zero number. So over here, we would write 10, and our exponent would be to the negative 5th power. And you might ask, hey, why is it to the negative 5th power? Why do we have a negative exponent up there? And the reason for this is because we are dealing with a number smaller than 1. And when we have numbers that are smaller than 1, the exponents are negative. We'll see over here in this number that is obviously greater than 1, we have no decimal point, our exponent will be positive. But we'll look into that in just a second. So, second number, let's do this again. So the first thing to identify is our number greater or smaller than 1. We have that decimal point again, so this number is smaller than 1. Identify our first non-zero number, and that's that 3 right over here. So this is going to equal 3. And we have to write in every single number after that first non-zero number, and we include a decimal point, 3.47. Multiply it by 10. And what is the exponent? Well, again, we count up every single digit, including that first non-zero number. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 3.47 times 10 to the negative 8 power. Negative 8, and again, we have that negative sign because we're dealing with a number that is smaller than 1. Let's take a look at our last example. Our last number, and here we have a very large number, so I'm going to include some commas just to make this easier. Okay, the first step we have to do, of course, is identify if our number is greater or less than 1, and obviously this is greater than 1. Then we identify our first non-zero number, and that's this 9 right over here. So this is going to equal 9, and again we write in every single number that is greater than 0 afterward with a decimal point. So let's go 9.62. We multiply that by 10. And then we see, hey, how many numbers, how many digits are after that first non-zero number? Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers afterward. So this is going to be 10 to the positive 9th. And just like that, we have written each of these 3 in scientific notation. And just as a reminder, the first thing we do is identify if a number is greater than or less than 1. Numbers that are smaller than 1, like these two, have a negative exponent. And numbers that are greater than 1 have a positive exponent. When we're dealing with numbers that are smaller than 1, we count up and we include that first non-zero number. But numbers that are greater than 1, we count every number after our first non-zero number, every digit after our first non-zero number. And I hope this video was helpful and it helped clarify some questions you had concerning scientific notation. Thank you for watching. If this video was helpful, make sure to leave a comment down below, and like always, stay positive.